Assalamu alaikum. Bismillahirrahmanirrahim. Welcome to our JNCIS-SP service provider course dedicated from Juniper network. So today we discuss about OSPF. Uh, Today I try to deliver theoretical part of OSPF, and next class we will deliver practical. Okay. What is OSPF? The OSPF is open shortest path first. It's a ICP, okay, interrogated protocol. If you think that you are just running a service provider network as an administrator, so you have to use one ICP in your own router, in your own ASN router. Okay, so you can choose any ICP. It can be static, and it can be RIP, it can be OSPF, and it can be ISIS. So OSPF is best option. Everyone choose this because this concept and configuration is very easy. Other than ISIS and others. And RIF have some limitations. You already know. That's why we use OSPF, commonly OSPF, as a ICP in service provider background. Okay. So say this one. Just a overview of OSPF. This is service provider. Service provider have own ASN, and you can consider it's a customer. Customer have own ASN. There is no public IP and ASN. That's why customer use the private ASN. It can be different. Customer have own IP, public IP, and public ASN, and they have multiple router and configure OSPF in their routers. Okay. So it's not mandatory. It's should be private ASN. It can be private ASN. It can be public ASN. You can configure OSPF within the private ASN as a IGP. You can configure OSPF inside public ASN multiple router as a IGP. Okay. So OSPF, it's a ICP, interrogated protocol, commonly used within a autonomous system, and it's a link state routing protocol. Okay, and OSPF floods link state advertisement. That means routes through the LSA, link state advertisement. That means consider there is 4 router here, and multiple network is connected. Consider here one LAN is connected here, another LAN is connected here. Every router have individual LAN connectivity. So this LAN have multiple network. It can be multiple. If you deploy the VLAN, it can be one network or multiple network. Just consider single network. This 4 router have for individual LAN network. So if you need to communicate between one LAN to another LAN, need routing protocol. You can configure here a static routing protocol, but this is a very administrative dependent protocol, and it's a manual. Okay, so if I choose the dynamic routing protocol, OSPF could be a best choice for this environment. Okay, so if just this route is advertised through the OSPF routing protocol in the another OSPF neighbor, this route is called the LSA. This route is called the LSA basically. Okay, so OSPF floods routes. Why floods? They floods this router, and this router. That's why this word is called, this word used here, floods. Because OSPF use multicast. You know, OSPF use multicast to communicate between neighbor. So, OSPF router use the registered LS to create a complete database of the network. So this router maintain a database that is the OSPF database, and OSPF have different type of database that's depend on topology and depends on area mapping. Okay, so I will discuss details in coming slide. The LS type, different LS database type or LS type. OSPF uses the shortest path first, that means SPF algorithm to calculate the base path. So if you consider here, this 4 router is connected with each other like this. It's a ring network. So if you think here is one LAN network, another is LAN network. So see here, this router also connected like this. This is a ring and also connect like star. Okay. So if I want to reach from here, just consider OSPF use the default matrix. If I want to reach from this source to this destination, this path will be the shortest. This path will be the shortest path. Okay. And this path will be the longest path, and this path will be the longest path. Consider router, every interface is same. It can be 1G, it can be 10G. Okay. So to calculate the shortest path, OSPF use the SP calculator to reach the destination. Okay. Yeah, this one. It's a very basic overview. And the link is the database. Link is the database. That means just consider here, you add one network from router 2. This network is added in this router as a direct route. If this router added this route in OSPF network, this route will be advertised towards the neighbor. They will get one update here. Just write the database and enter this new entry. And every router doing the same thing. This route, this OSPF route is called the database, linked database. So database content consists of information learned through LSA and must match all routers within an area. Within an area means, if just consider here the four routers in a area. This is a single area deployment. If 4 router in same area, all router or each router have identical database. That means this route will be in router 1 database, router 4 database, and router 3 database. Every database have this route. That's why called identical copy of database. SPF algorithm uses the contents of the linked database as input data to calculate network paths. Creates a tree of shortest path incrementally and picks the best candidate from the tree. Hands over the calculation results the routing information base. That means they calculate the database and just calculate the database like this. This route is connected in router 2. So if I install this route in router 4, there have multiple paths, this path and this path. Both paths will be installed in RIB, routing information base. Both paths will be installed in RIB. So there is another table that is called the FIB, forwarding information. And FIB, this route, when this route installed in router 4, FIB routing table, only best one will be installed in FIB. That is the difference between RIB and FIB. Is okay. OSPF packet types. When one router is communicating with the neighbor router through the OSPF routing protocol, OSPF peer router send this type of packets. This type of packets. There are 5 types of packets. Number 1 is hello. Hello here basically used for checking neighbor is live or not. Neighbor is live or not. Database description used to share the local database with the neighbor. And link state request means just asking the neighbor if any LSA missing on the router. Link state update, that means all OSPF route will be coming or sending from router. It's called the link state update. If any link or network disconnected, OSPF domain, all routers have to update through the link state update packet. And link state acknowledgement is just after updating all of the router acknowledgement, the LSA that is now synchronized all routes in our route table. So here is 3 types, type 3, type 4, and 5, link state request, link state update, and link state acknowledgement. So see the direction. Link state advertisement are flooded reliably using link state request, link state update, and link state acknowledgement. This is the flooding. So here, router 1 just have some route like this. Think here is one network is here. This network is coming in router 1 and install OSPF route table because R1 and R2 have OSPF neighbor. So R1, if this network disconnected, R2 stop advertise this network through OSPF neighbor, and R1 for some time, because hello will communicate after 10 seconds. After 10 seconds, and our OSPF dead interval is 40 seconds. In 10 seconds, just you consider the 40-second dead interval. This router just coming one packet in router 1, and the destination is this. This is the destination. Router 1 have route table for this destination, but this destination is not reachable. Just sending packet to router 2 and packet is dropped after coming router 2. So router 1 need to send their neighbor, they send the request, this route is getting from you, but this route is not communicating. So in that case, they will send the update message. This route is not available now. Just withdraw your route withdraw this route from your OSPF route table. This is the acknowledgement. This is the acknowledgement. Taking update and finally sending the acknowledgement. So this is the process basically. So first one is hello. So multicast hello packets are used to establish and maintain OSPF neighbor relationship. I already tell OSPF use multicast to communicating OSPF neighbor. In a OSPF domain, there is multiple router, maybe multiple router, and all router will be communicating through this multicast IP for IPv4. And for IPv6, they will use the different IP. So this is the hello packet, and inside hello packet there is multiple information communicating between the OSPF neighbor. So first one is network mask. So consider here who is network mask. Who is network mask? Just consider here this is router 1 and another is router 2. This is router 1 and this is router 2. This router have point-to-point IP address. So what will be the mask? It can be /30 for IPv4, or it can be /31, or it can be less than 30. Okay. So if I configure the address between this router, there have network mask. So neighbor send the network mask information to neighbor. Okay. So if we configure the OSPF between two routers, the two routers point to point, when you choose the point to point IP, those point to point IP network mask should be matched. Okay, this is the number one. Number two, hello interval. OSPF use hello interval 10 seconds by default if network type is point to point or broadcast. If broadcast and multicast, other than this, they will use a separate hello interval. And the dead interval is default 40 seconds. Dead interval means if this neighbor disconnected, it can be fiber cut or it can be router power shutdown. It can be anything. They wait for 40 seconds. They wait for 40 seconds. Neighbor is live or not. If neighbor is this router, if this router not communicating the neighbor, this router declare those neighbor will down. This neighbor goes down. And this is the another options. Options means you can add any information here. This is the extended information. Router priority, router default priority is 1 to 8. Router priority basically we use to select the designated router and backup designated router. Designated router, those router priority is higher or IP address is higher, those router will be the designated router, and lower than highest priority or IP addresses, those router will be the backup designated router, and others router will be the DR other. And this is the neighbor information. So this information will be in hello packet. If one router sending hello packet to another neighbor, this hello packet will contain this type of information. Okay. Network mask. First one. Network mask is evaluated only on Ethernet links. All router must agree on the subnet mask of the link. That means you have to maintain one subnet two routers. Between two routers, you cannot use different subnet. Okay. Hello interval. Two routers agreeing on the frequency of hello packets to be shared. That is called the hello interval. So if you just configure hello interval in router 1, hello interval is 5, and router 2 hello interval is 10. So there is a hello interval mismatch. If a hello interval mismatch, OSPF will not communicate. Like hello interval, dead interval is like this. If dead interval time is not matched between the OSPF neighbor will not establish. Options, this is the 8-bit field for OSPF operation. And second one is type 2. This OSPF packet type is database description. So what is the function of database description? So database description packets are exchanged during adjacency formation to determine which router monitored database exchange. Describe the contents of the LSDB, linked state database. That means one router have one router have their own database. They will share or exchange with neighbor. This step or this type of packet is called the database description packet. So database description packets are exchanged during adjacency formation to determine which router monitored the database exchange. So consist of OSPF header, sequence number, LSA header. Just think it's a database. So if you consider one database have multiple entry. Okay, multiple entry. They maintain the sequence number. That's the router with the highest router ID, that means RID, is the primary router of the synchronization process, while the other is the backup router. That means the highest router ID will be the primary synchronization router in OSPF routing domain. So if you consider in OSPF domain, so you have to set the highest router ID in a healthy router. Those router have more resources and those will handle more packet. So in the, when you consider to deploy the OSPF in your network, so choose better one router and choose their highest router ID so that OSPF running smoothly. The primary router set the maintenance sequence numbers. The primary router or backup router relationship is forgotten after transfer. DD packets are also used to transmit LSA header. So this is the information of database description packet. One thing is primary router. You have to consider when you design the OSPF, you have to consider who one will be the primary router. And those router should be higher model. Database description packet. Another option is the sequence number. And last one is the contain the LSA header. This table basically there is multiple OSPF header, there is for multiple LSA. Those have individual sequence number. This table should maintain every OSPF neighbor so that all route will be synchronized in every or is OSPF domain route. So third packet is link state request. Link state request packets are sent by an OSPF router when that router detects its database is stale. Database is stale. Previously, those route is in their database, but now the database is stale. In that case, they're sending they will send the link state request to neighbor. This is the reason of link state request. Are used to request precise version of the database, consist of the OSPF header, link state type, link state ID, and advertising routing. Is the link state request. In link state request, there have OSPF header, link state type, link state ID, and advertising router. That means if R1 is advertising some routes or some LSA to R2, so there have advertising router is R1, link state ID, they have specific ID and link state type. It's a P2P link or it's a broadcast link. Those type of information will be in link state type, and OSPF header is common for every packet. Hello packet, database description, link state request, link state update. Every packet have OSPF header. So link state request, same one, advertising router, and link state update packet. Link state update packets are the basic information block in OSPF and carry multiple LS. When three packet is communicating between the two OSPF neighbor, fourth packet is link state update. This packet basically update all OSPF routes which is coming from neighbor. Okay. Transmitting using multicast to either the all OSPF router address, this IP, and all designated router IP address this. If you use the network type is broadcast, in that case, designated router and backup designated router have to be selected, and for that reason, this multicast IP is used. Other than this, commonly OSPF use this multicast IP to communicating all the OSPF domain router. Link state update packet. Link state update packets are the basic information. It's the same thing. Consist of OSPF header, number of advertisement, and LS. Which information carried in link state update packet? OSPF header is common. Number of advertisement and the link state advertisement. That means how many LSA or how many routes will be delivered to neighbor. That information will be stored in that table. That link state. It contains the full LSA described OSPF LSA downloads. Okay. And last one is the link state acknowledgement packet. Link state acknowledgement packet. So why use link state acknowledgement? Link state acknowledgement packets are received in response to link state update packets. If link state update is coming and need to synchronize all the router who are in OSPF domain. And this synchronization will be happen from primary router. Those router ID is highest. Okay. So this is the acknowledgement from every or its router who are in OSPF routing domain. Forming adjacency. If you just forming adjacency, that means OSPF adjacency or OSPF neighbor between two routers, you have to follow multiple steps. I have to follow router, I have to follow the multiple step. Just consider there is two router R1 and R2 connected with each other, and you just configure point-to-point IP address. OSPF yet not configured in router 1 and router 2. This state is called the down state. This state is called the down state. And in down state, hello designated router is 0 and sane is 0. That means nothing will be communicated in down state. And see here, second step is init. Init step means you are just configuring OSPF in router 2. Router 2 connected interface, who is basically connected to router 1. This interface is OSPF capable. R2 is attempt to send hello packet through this link, but R1 yet not configured OSPF. So R1 will not receive this packet. This packet, this step is called the init step. And third step will be the two-way step. Two-way means just init packet is received. You are just configuring done in router 1 and sending the hello packet to neighbor router. This step is called the two-way. Two-way means both-way communication should be happening. If both-way communication done, two-way step have completed. And fourth state is X-start state. In X-start state, basically database description packet, that means DD packet, will transfer between two routers. DD packet will transfer and receive between two routers. In this state, router will select who will be the primary router and who will be the backup router. It depends on RID, and RID depends on priority and the loopback highest IP addresses. If designated router and backup designated router selected in X-start state, they will go to the XNG state. They will go to the XNG state and confirm. Example, R1 is the designated router and R2 is the backup designated. After completing this selection, just sending this 4 requests. In loading state, they send the link state request packet, link state update packet, link state request packet, link state update packet. There is multiple because there is both-way communication. Router 1 sending request to router 2, router 2 sending update to router 1, router 1 sending update to router 2, and then send the request. Both-way communication. That's why there is multiple request, update. And finally, OSPF neighbor goes to full state. If OSPF goes to full state, then you can communicate. Your different network can communicate with each other. So this is the final state of OSPF. So this is the formation of this OSPF state. Then second one, adjacency optimization. So here, see the topology. Multiple router is connected through the switch. This is the switch network, and all router is connected with switch. All router is connected with switch. See here. So this is the broadcast network. Here 1, 2, 3, 4, 5. 5 router is connected with switch. So by default, OSPF attempts to form adjacency with all neighbor discovered on all interfaces. On a broadcast media link Ethernet, this approach is suboptimal because it could be require a full mesh of adjacency. That means like this. If you want, normally, if you consider here, this is router 1, router 2, router 3, router 4, router 5. So if I consider router 1, need 4 neighbors, 4 direct neighbors. Okay, need to configure 4 direct neighbors. Every router have to configure 4 direct neighbors. So all router is connected through the switch. In that case, if I consider this is a designated router and this is the backup designated. So these three router is DRR. If this router only configure with designated router and backup designated router, designated router and backup designated router, designated router and backup designated. So every router neighbor will reduce. Neighbor will reduce. You can do this if your network is broadcast. Okay. This is one optimization. Second one is adjacent optimization part 2. OSPF elect designated router to represent the segment, minimize OSPF process and reduce the traffic on segment. Basically same thing. To reduce neighbor, to electing designated router and backup designated. Okay. Adjacency optimization part 3. This is the best way. This is the best way. Basically, if you deploy to router and configure the OSPF, just connecting to router through the Ethernet cable, it can be like this. Just connecting Ethernet cable from router 1 to router 2. It can be switched between this router. It can be, but when you configure the point to point of these two routers, just consider /32 to make OSPF neighborship between this router, and you just configure interface type is P2P. If you configure the interface type is P2P, that means one LSA will remove from here. Designated router, backup designated router will not elect here. So you reduce the OSPF routing masses. And you can say this is the optimization. Okay. So OSPF interface type point to point, no designated backup designated router election occurs. This is the number one. Use between adjacency involving existing two neighbors, set the guiding the adjacency to a full step, useful back-to-back Ethernet links. Back-to-back Ethernet links. It can be direct links between two routers, or it can be indirect links through the switch. So if we configure OSPF neighbor in our production, we should use this one. Interface type is P2P. That is recommended. So electing the designated router, how to elect the designated router and the backup designated. It's basically depends on priority. If priority is higher, those router will be the designated router. See here, priority is 255 and backup designated router priority is 128. So higher priority router will be the designated router and lower priority will be the backup designated. And default priority is 1 to 8. Router default priority is 1 to 8. If you just consider here, you yet not set the priority value. So consider here, both router have the default priority and the default priority is 1 to 8. Default priority is 1 to 8. So what will be happen? Choose the second one. If two routers share the highest priority, the router with the highest router ID is selected. Both have 255 or both have 1 to 8. So highest router ID will be the designated router. Here, the highest router ID is this one. The election of the designator is non-deterministic event. An existing router will not be replaced. Fast router on the segment 40-second wins. Backup designated router is elected using the same election rules, which are already discussed.
Sir, here is the previous place, please. Here is the router ID for BDR is the highest IP, but it's elected as a BDR. It's not sure, right?
In this scenario, this router is better because the priority is low. If you set priority default, bidder will be there. Okay.
Okay.
And others, next scenario is OSPF neighbor versus adjacent. Consider here, there is 4 router here, and this is the you can consider this is the designated router, and this is backup designated. Okay, and this router is DRR. Just consider. If you check the OSPF neighborship in router one, see all 3 OSPF neighbor is up. All 3 OSPF neighbor is in full stack. This output from router 1. If you take output from this router, you will get same. But if you get or take OSPF neighbor list from router 3 or router 4, these 2 routers, the state will be like this. First one is designated router. Second one is backup designated router. And 1.3 is DR other. That means DR other, between 2 DR other, the state will be two-way. The state will be two-way. Because, or if you just consider your designated router is disconnected. So this router will be the designated router, and router 3 or router 4, anyone will be the backup designated router. In that case, two-way relation will be converted to full stack. So if you see neighbor state is two-way and topology is like this, DR other and DR other, this is okay. If the neighbor state is two-way, but your connectivity is DR and DR other, or BDR and DR other, but your state showing two-way. In that case, there is a problem. In that case, there is a problem. You have to troubleshoot. But in that case, this is the normal. It should be two. OSPF scalability. It's basically in this section we'll discuss about OSPF area. Scaling of OSPF network. Consider here multiple router is connected. Only OSPF area 0 is deployed here. So in OSPF 0, all router is connected. So in that case, OSPF 0 link state database will be increased. OSPF database will be increased. If we segment in a smaller area, if we segment in a smaller area, number of database increase, but database size will be decreased. So if you you have just this is the recommendation. If you have more than 50 router in your network, you should segment your network in multiple area, multiple OSPF area. Okay. If you deploy multiple OSPF area, that reduce the LHDP size and your OSPF performance will be better. Okay. Well, this is the OSPF areas. This is the just name. You can set name as a decimal value, or you can set the OSPF area name as a dotted decimal point, like IPv. This is the backbone area, 0.0.0.0. This is the backbone area, and 0001 is the non-backbone area, and 002, this is also the non-backbone. So every non-backbone area should be connected with backbone area. Other than this, you will not get LSA from one area to another area. So this is the limitation. You can say limitation, or you can say recommendation. So OSPF areas, an autonomous system can be divided into smaller groups called areas. These groups is called the area. Link state advertisement flooding can be constrained to an area which effectively reduces the size of the LSTP. I know this. All routers maintain an identical copy of the LSTP on a per area basis. Basic. So see here, if one route is connected in this router, this route firstly advertise the OSPF neighbor and coming in backbone area and then goes to another area. So here, area 0 or backbone area working as a transit. When one area is communicating with another area. Okay. So all packet traffic between OSPF area transit the backbone. After default behavior, eliminate the requirement of all inter-area traffic. So this is the design of OSPF when you deploy in your network. So there have some terminology in OSPF network. One is area border router. So who is the area border? Area border router is basically connect between backbone area and another minimum non-backbone. ABR can be connect with multiple non-backbone area, but should be connect with backbone area. This is called the ABR and ASBR. Who is the ASBR? So ASBR here, if OSPF router, if OSPF router is connected with another routing domain router, like it can be connect through BGP, it can be connect through static, or it can be connected. All are other routing information sources. So if this type of routing protocol is connected with OSPF router, this router is called the ASBR, Autonomous System Border or Boundary. And who is the internal router? Those routers only connected with this area. This router, look this router is connected in area 2 only. But this router connected with area 2 and the area 0. So this is called the ABR, area border router. But this router is called the internal router. This router is called the internal router or not? Is this router called the internet router or this router? Is this internet router?
Internal router.
Internal?
Yes.
Yes, internal. These are area 0. And you can say this is a backbone router. Or you can say this is a area 0 router. So there have multiple names. Okay, multiple name. So this is the basically terminology of OSPF router. So OSPF use multiple area types. Default OSPF use the default area or normal area. There have no restriction in normal area. Every route can go and come and go from one area to another area. But if you configure the OSPF spatial area, that have some restriction. That have some restriction. See here, this is the backbone. This is the backbone area. And this is, you can say, another area. This is the non-backbone area. This is the non-backbone. So this is the area type name, stub area, totally stub area, north stub area, and stub, totally stub, north stub area. But NSSA, now other type will be here. Okay. First one is stub area. When you configure one area, what as a stub area, so those area router have only inter-area routes, intra-area routes. That means these area routes will be available on that router. And type 3 route, if backbone have type 3 route, those type 3 route will be coming here. But type 4 and type 5 route will not coming in stub area. Totally stub area, type 3 route will not be coming here. Only default route will be coming here. And intra-area route will be in totally stub area. And no redistribution happened in stub area and totally stub area route. But if you configure NSSA, not stub area, redistribution will be happened in side stub area route. You can redistribute any domain, any route. It can be static or it can be getting from BGP. Those route will be advertised to backbone and other area. That means plotted will be all other area. So this is the special type of OSPF area. We'll configure in our lab next class. So this is the another picture. Only default route is coming here. Okay. So already discussed, and this is the overview of LSA packet. LSA packet. There is multiple LSA type in OSPF routing domain. Number one is LSA type 1. LSA type 1 is called the router LSA. And the router LSA means it describes the state and cost of the router's links interfaces to the area that is called the intra-area. Network links, this is called basically type 2. If your network is broadcast network, then type 2 will be exist. Type 2 will be exist. Otherwise, type 2 will not exist. Summary links, if one route is coming from one area to another area, this route is called the type 3 or inter-area route. It can be type 4 if that's coming from ASPR. If routes coming from ASPR, that will be type 4. If the route is coming from ASPR, but this route is redistributed or external route, that will be coming from static, or that will be coming from direct or BGP. If we receive the external route, those link is a type will be fine. And last one, the link is type is 7. If you configure the OSPF area as a NSSA and one NSSA router redistributed static or any external route towards the area or another area, those external type will be the type 7. So these are the LSA type was used in OSPF routing protocol. And there is others LSA type like type 6, basically used for multicast. Type 8, this is the external attribute for LSA. type 9 and type 10 basically used for IPv6 and type 11 yet not used. So when you configure OSPF for IPv4 and IPv6 in our lab, we'll check the LS type. Last one, and this is basically knowledge review. So see here, the spatial area configured here. So which of the areas would you expect to find in each of the listed areas? You should participate in question answer section. So first question is star area. As external advertisement are not flooded, LSA type 4 and 5. This star area will not receive type 4 and type 5 routes. Totally star area receives only the default route from the background. And NSSA enable type 7 LSA which represent external route flooded within the area as a type 7 along with type 1, type 2 and type 3 LSA. So if I consider it, just see this is the backbone area. Here, which route is coming in this route? Which route is coming in this route? This area configured as a totally stub area. Anyone?
Only default route?
Only default. Perfect. See here, it's a NSS area router and connect with another router, but routing protocol is static. This router redistribute this static route. If I check here, this static route is coming this router also in this NSS area router. If this static route is coming here, so what will be the type? Is it type 1, type 2, or what is the type number of this route? Redistributed static route here, and when this route is coming in this router or in this router, so what will be the type? Is it type 5 or is it type 1? Static route will be converted in type 7 in this router or type 5? Type 7. If this type 7 route advertised towards the backbone or other area, those route type will convert it to type 5. That means in this area, route type will be 7 if this route is advertised from ABA router to another area, it can be backbone. Those route will be converted to type 5, type 7 to 5. Same route. In this area, we will see this route is in type 7, but if I see from this router, same route, but type is 5. So that's all for today. I think if you have any query, you can ask. In the next class, we will see lab of OSPF, that is deployment of OSPF. So if you have no question, I have to stop now. Okay, thank you.